Hello, good day, and welcome back. Here, let's look at um, integration by parts. Let u and v be a function of x. We recall from the product rule of derivative that if f of s is equal to u of vu, that means v is a function of x and u is a function of x. By applying the product rule, we obtain that d ds of uv is equal to u dv ds plus v du ds. Okay, here in integration by parts, sometimes a function may be involving products, okay, which are not related. Okay, the appropriate method is to use integration by parts. Okay, the first thing to do here, we use this the product rule of derivative to establish the formula for finding uh, integration by parts. Okay, so here if we apply integral dx on both sides, we see that this becomes integral d dx v u times dx is equal to integral of u dv ds times ds plus integral of v du ds times ds. Okay, we are integrating throughout with respect to the x, integral the x. Okay, now you can see that the x will go off with the x here, and the s is off with the s, and similarly the s is off with the s. Here we have the integral on the left hand side. This become integral v u v. Okay, now but all you need to know here is that this integral sign here simply means 1 over d, and that means 1 over d times the d at the numerator here. The left hand side becomes uv is equal to integral u dv plus integral v du. Then making v du subject of the relation, they become uv minus integral of u dv. Okay, now let's take a look at example of what we're trying to look at here. If we have a function of this, an integral of this type, integral log x to base e dx, that is integral in x. That's one example of integration by part. Here we have number 2, integral s squared cos s dx. You see that there are two functions entirely, okay, and they are not related in any way. Okay, so here the appropriate method is integration by parts. Here look at number 3, we have an integral x exponential x dx. Then number 4 is integral sine open bracket x dx. Okay, now to use these techniques, the following condition must be strictly adhered to. Okay, one of the conditions is that one function which is the second function must be integrable. Okay, there are occasions where the two might be integrable, but there are also occasions when one will be integrable and the other one will not be integrable. So you choose the second function as the one that is integrable. Okay, then the second condition is that the other function, which is the first, is never integrable. Okay, the first is never integrable. Thus, if this method is used to integrate the product of two functions, we first look for a function which can be integrable immediately. If there is only one, this is taken as the second function. Okay, then thirdly, if both functions are integrable. Okay, if both functions are integrable, we generally choose the first, the one which simplify most on differentiation. Okay, now this is the simple formula here. Imagine having the integral of the first times the second is equals to integral is equals to the first times the integral of the second minus the derivative of the first times integral of the second. Okay, let's go into practical example. Example 1, the integral of ln x dx, okay, of the natural logarithm x to base e dx. Let's do for the integral. Here, note that ln x, okay, we can also write it as ln x in this form. Log x to base e can also be written as ln x. It therefore means that integral of log x to base e dx can also be written as integral ln x dx for short. Then here, this integral can also be expressed as ln x times 1 dx. Okay, here this has to be done because we need to identify which of the functions will be second and which one will be third. That is, which one should be v and which one should be the u. Okay, from here, remember the one that is v is the one that is differentiable, the one that is cannot be integrated, or that is the one that is not integrable. So if one is not integrable, then the other one should be differentiable. All right. So here, integral of v du is equal to integral of uv or vu minus integral of u dv. So now let our du is equal to dx. Then that means that our v is equal to ln x, because ln x is never integrable. Okay, let's take note of that. Now we will apply the integral, the integral sign to both sides of the u is equal to ds, and this becomes integral du is equal to integral ds. Here, if you recall, I mentioned that this integral, this symbol here, is 1 over d. So here, 1 over d times the u become u, and 1 over d times the s it become x. Okay, that has performed the simple integration. Okay, now similarly, to obtain the s, we have to find the derivative of x of ln x in equation 2. So here the v ds is equal to 1 over s. It means here we know that to integrate ln s is 1, the result is 1 over x. Okay, now for us to obtain the v alone, we multiply through or both sides by the x. So the v ds times the s is equal to ds all over x. Okay, this gives the v is equal to the x over x. Now, if we substitute the v and u and the v into the expression, here we have our u is equal to x and v is ln s. So x times ln s minus integral. Here we say is u dv, and our u is x and the v is the x over x. So that x we cancel x, and this become x ln x minus integral of 1 ds. And if we apply the integral upon, if we integrate 1 here, this become x. So this become x ln x minus x plus c, where c is an arbitrary constant. Okay, and that is necessary in integration. Okay, here we can also factor x You look at here, there is x. Here, we look at this part is x. So if we factor out x, this becomes x open bracket ln x minus 1 close bracket plus c. Hence, integral of ln x dx is equal to x ln x minus c plus c, where c is an arbitrary constant. This is how to to use integration by parts. First, you must look for the two functions, which one is integrable and which one is differentiable. Okay, that will guide you. Please, all you help me subscribe to my YouTube channel and hit the notification button. Once similar video like this comes up, you'll be able to have access to them. Have a nice time. See you in my next virtual class.